Cool. So, how about that TikTok?
All,
Okay, well,
all in for Redshift.
All about Redshift.
All in for Redshift today.
welcome everyone. See, people are slowly starting. We will begin, in a couple of minutes. I know it takes a moment for everyone to get through the GoToMeeting webinar, so just give us a second as we wait for more attendees. For those that just joined, we're waiting on a few more people to jump in. We see the attendee list going up, so bear with us for a quick second, and then we'll get going on optimizing Amazon Redshift with our hosts, Nasseer and Scott. For those that are joining, I'm sure many of you have used GoToWebinar before. There's question tab at the bottom. Feel free to put in your questions, whether you've come pre-prepared or while people are presenting, and we'll be monitoring that channel and answer any questions that you have during the meeting. Just going to wait another minute or two for the attendees to all be able to sign in, and then we will begin. It's always interesting as we wait here. Time seems to move very slowly as you wait, even though it's only been a few minutes. I think more people will start trickling in, but we'll begin the presentation. I will start our conversation and then hand it off to Nasseer and Scott. Our presentation today is about optimizing Amazon Redshift. And we'll have a few surveys as we go along, and excited to talk through a lot of this information that Scott and Nasseer have used in their journey in AWS and helping enable customers. Next slide, Nasseer. So just quickly, Ryan Ries, I lead Mission's data and analytics and machine learning practice. We're here to help any customers anywhere they are along their journey, right? We focus on data and analytics, which part of, the Redshift is a big piece of that. So we really help customers that are using Redshift, looking to use Redshift, have Redshift and need help optimizing it. We also have our machine learning capabilities where we can help you with data scientists and some of the cool new features that we talked about last time with Redshift. You can put your models in Redshift itself and use the compute nodes there. So really awesome functionality. And finally, we have ML Ops, where we can help you guys, if you've made models, put those into production and keep them in production. The slide before is here. So who are our presenters? We have Scott Clark. He's one of Mission's big data consultants. He works closely with customers both in the pre-sales and the afterwards in delivery to help build the best possible solution. And we have Nasseer Slim. He's been working in the AWS and the data space for many years. He's one of our senior big data engineers. He's focused often on Redshift projects and has spent a lot of time in the BI world. So really great resource for you guys to ask any questions to today. Next slide. So quickly, who is Mission, right? Mission's a premier consulting partner. We've worked with AWS for a very long time. We're only focused on AWS. We don't work on any other clouds. We do this because, as you guys are aware, AWS has over 400 services, and we believe in the concept of mastery, where you really need to focus on one of the hyperscalers in order to really understand all the pieces and give the best value to any customer. As a premier consulting partner, right, we've gone through and been vetted and validated and verified by AWS. We have tons of public use cases out there, and we have a lot of the various certs and competencies, as well as verticals that we've been validated by AWS that you can see below. Next slide. So today's agenda, obviously we just got over the quick blurb about Mission Cloud. Then I'm going to talk a little bit about the analytics landscape. I know some of you guys probably saw this last time if you were here, but just going to go over that briefly. Then the team's going to talk about why customers choose Amazon Redshift, deep dive into the architecture, talk about data warehouse migration process and journey, how to prepare and plan for your data warehouse migration, and then the migration toolkit to accelerate that data warehouse. And then we'll go through Q&A. I actually think that's the wrong agenda slide this year.
It is. So I think our decks got a little backwards, but ultimately what we're going to talk about is, we've been through the about mission. Ryan's going to talk more about the data landscape, data analytics landscape. We're going to, for those of you that attended the webinar a couple of weeks back, we're going to touch back on why people are choosing Redshift, just to give some background, and also recap on a little bit on the architecture. Nasseer will deep dive into monitoring, optimizing, and managing Redshift, and then I will take it home by talking deep dive into Amazon Redshift Spectrum, and then we'll open it up for questions.
Hey, sorry about that, everyone. So let's just talk about the data analytics landscape. Next slide. So as many of you guys know, in the early 80s, everything was on-prem. You really had this concept of a data warehouse where all your ETL was coming in. You created a bunch of data marts for each of the different divisions of your company. And then people were making BI or making reports and all of those pieces that were really critical to the business. And as the cloud started to take prominence in the 2000s, and then in 2011, you really started to see the data lake concept starting to be born, where now you're putting all your data into S3. You had all kinds of different types of data in there, right? Previous slide this here. You had all kinds of data there in the data lake. Some people were doing real time. Some people were still doing the data marts, but you're really starting to see an evolution that was going on with how people were handling their data. And now people are really looking more and more at this lakehouse architecture, which is really trying to create more of a real-time, more of a streaming presence where you can get that real-time dashboarding. You're getting your models running full speed. You're really looking at that forefront. And to get to the lakehouse, Redshift has made some changes over the last couple of years to really be a main focus point in that lakehouse architecture. Next slide. So kind of what does your basic data infrastructure look like, right? This is kind of what a lakehouse implementation looks like. You've got in the middle your data lake storage. This is our S3, where you usually have a raw zone where you drop your data in, and then you've got this transform zone where you've run some ETL jobs there to really just clean up your data, do quality checks and all that. And there's a lot of important pieces that are around your data lake storage, right? What kind of data governance strategy are you going to have? How often are you going to keep your data on S3? How often before you roll that back down into like Glacier or something else? There's a lot of compliance rules. There's a lot of other rules where people need to store that data for 10 years, right? So you really want to make sure you have a good strategy of how you store that data. Obviously, security, super critical. You want to make sure you've got a good security process, and then monitoring, right? You want to be looking at this data coming in, understanding, am I seeing anything strange? Just making sure you're auditing and logging everything that happens there. So on the left-hand side, right, is that ingestion where you're going to be pulling data from your data source. There's a lot of tools out there for that ingestion layer, right? Maybe you're pulling something through API gateway. Maybe you're using DMS because you've got something on-prem that you're going to pull in. Could just be glue jobs or many other tools that are there. And then we always like to start on the far right where we look backwards, right? What exactly are you trying to build at the end of the day? Is it going to be a dashboarding reporting solution? Is it for an app? Is it for your data scientists, right? Each of these pieces have specific requirements for what your data looks like. Often if you're doing that dashboarding and even the data science solution, you want to put your data into a data warehouse or a data mart, and that's where Redshift comes in, right? It's one of the best data warehouses that is out there. We love it. We use it all the time for all of our customers, and you'll do ETL off your transform zone to get your data there. Next slide. So, in the past, what was going on before more people have started adopting this lakehouse architecture and other things is people are just collecting more and more data, right? They're just throwing data, any kind of sensor, any kind of source, just push that data to S3, which obviously has a lot of issues that you go, right? You've got a lot of cost, you got a lot of different pieces that you've got to deal with there, just like, how do I even sort through this data? How do I do anything? So you really need to go about figuring out a really good data lake solution that will help you understand your data, help you democratize it so that anybody can use it, right? In the old days, you had data silos where, finance would have some data that you could never touch because it was off in a different area. So it's really been a boon to everyone for these data lakes where you can see all the data and you can really have your data scientist access these different pieces. I've helped companies where they're trying to build a model, but finance might be holding some of that data that they need, and so they can't even build a full predictive model just because they don't have that data. So it's really important to allow that democratization across your organization so that you can build really good models that are going to help inform your company and push your business forward. Next slide. So as you guys all know, you've probably seen this tons, right? Nowadays, the most valuable resource is not oil, but really data. Everyone's trying to mine data. Everyone's trying to understand what exactly is out there. How can I use it? How can I make the customer experience better? How can I, we work with people in supply chain and everything else, right? How can I predict when a customer is going to need something so I can have already basically pre-ordered it for their use? And just a little bit of something that's crazy if you think about it. Nowadays, with all the IoT sensors and everything else that's out there, every hour you create more data now than there were 20 years ago, right? For that entire year. It's pretty impressive just the sheer amount of data that's being created. And just think about the processing that has to happen in order to gain those insights from all that data. Next slide. So, obviously today we're here to talk about Amazon Redshift. I love Redshift. It's widely used cloud data warehouse, thousands and thousands of customers. You can put all of your data inside the system. It has massive scale, which we talked about last time. If you get on RIs, you can significantly lower your costs. So it's a great data warehouse to use. I, pretty much recommend it to everyone. Next slide. And so this slide just kind of shows a sample list of people that are using Redshift. This is very big companies are using this, not on this list, but, Netflix is a big user as well. You've got tons of different customers using Redshift all the time. Next. So finally, just a little bit of a definition here. A data mart is usually a single subject or functional organization piece, right? So this is often where data silos start to kind of creep in a little bit, but often, you have your finance department, they'll want specific schemas, they'll want specific data there. And, you create a data mart in that sense versus the data warehouse, which is where all the rest of your data is, because this is where you can really focus the tables and it'll be one of those optimization steps, right? So now you're optimizing that data for each of the different divisions, but you'll still have back in your data warehouse and your Redshift, your master data that you're always looking at. Next slide. So that's interesting on my screen. So I just want to put out a special offer for everyone that's here. If you guys are looking for help, we're here to work with you. We're offering a free one hour consultation to anyone to talk with basically, someone like Scott or Nasseer, talk about what you're seeing, what help you need. So feel free to schedule that, you can send an email to solutions@missioncloud.com, and we're here for you guys to, look at what you're doing, offer suggestions, and, see how Mission can help you guys with your Redshift. Or really anything else that you guys are looking for in the AWS space. As Premier partners, we not only have our data group, we also have many other groups that focus on different parts of the AWS stack. Next slide.
Well, thank you, Ryan. Thank you for that great introduction. Just to recap, my name is Scott Clark. I'm a big data consultant here at Mission. And before we jump in, I always like to give the audience, oh, we have a polling question. I'm sorry, I got ahead of myself. So are you working on projects to migrate customers' data warehouse into Amazon Redshift? Please select one of the following. Give everyone just a minute. Do we have the results of that poll? Oh, great, wonderful. So it looks like, the vast majority of you, almost half of you, haven't started this journey yet. With the next highest ranking one that you started to do proof of concept. All of these areas are areas that we specialize in, from starting at ground zero and migrating existing RDBMS systems into Redshift and into the Lakehouse architecture. So great, thank you everyone for participating. So before, go back up one, I think. Nasseer? Okay, yeah. So before we jump into that, I always like to sort of outline how the data analytics machine learning team at Mission operates and some of the principles that we work off of. So our main goal and where we start is for us to gain deep insight into your data, and even in many cases help you understand your data better. Then we move forward in building and defining a roadmap with very specific requirements for analytics workloads, machine learning workloads. And then finally, we take the two of those and align those with the AWS ecosystem tools and services, and in some cases, third party, maybe 25%, 30% of the organizations we work with, we are working with other AWS or third-party tools. And in doing so, we like to employ several different frameworks to help us achieve the above mentioned. And that is, I don't know if anyone's familiar with the concept of working backwards. Not an idea or approach that Amazon invented, but certainly one they've refined. And that is that, we look at the personas and the stakeholders, and that's where we start in building out and architecting solutions. We also like to frame everything around a modern data ops framework, which, for those not familiar, it's a take on DevOps, but with data at the focus in building pipelines and in building staging and dev and test environments, even for the data. And then lastly, we, as Ryan alluded to earlier, we are a well-architected partner. And so we use the well-architected framework to help align everything that I've just spoken about into the 5 pillars. And so, in other words, if your goal is cost optimization and reliability, then we prioritize those in the architecture. Or if yours is, security and operational excellence, then those become the driving forces. So yes, next slide, please. So, one of the challenges, and again, Ryan alluded to some of this earlier, but what are the challenges with legacy data analytics architectures? Well, one, the exploding volume of data, and it's coming from new sources such as IoT, there's new data types, and it all needs to be analyzed, and it all needs to be analyzed fast. So in many cases, in a pre-existing architecture, you had to move data. And you'll hear us mention a lot today that we don't like to move the data. We like the data to reside in one place and bring the compute closer to the data. So, these older systems were siloed. They were brittle in terms of having to move data around, which is less secure, obviously. And it became a nightmare and a real challenge to govern the data and to be able to secure it. Given this new, given all of this, you'll hear us refer to today a modern data lake architecture, which Redshift is a huge piece of. So let's go. So the lakehouse architecture, it all starts with S3. And customers have been building data lakes on S3 for years, more than any other cloud provider. Why? Because it provides so many different options, as the slide indicates. So everything, is centered around AWS or S3. And then you have Glue, and the Glue family of products, which does the ETL, does the data, it manages the data catalog, and all of this from data within S3. So again, we're not moving the data. And then it opens up all these other data stores that are purpose built, so that you're not trying to fit square pegs in round holes, so to speak. When you need a time series database, there is a time series database, specific use case. Same with NoSQL, or if you're wanting to build machine learning pipelines, it integrates with AWS SageMaker. And obviously, AWS Redshift is a big piece of that. So, and then the wrapper on top of it all is AWS Lake Formation, which provides as I like to say, a wrapper that provides the security, the data governance, fine-grained access policies and controls, and can manage that downstream. And as we'll see when we talk about Spectrum and Redshift, it's an integral piece of the overall modern lakehouse architecture. Next slide. So, Redshift is a fully managed data warehouse, modern data warehouse. You can perform, there's some very neat features, and they're always, I think there's been over 200 service improvements or new services added in Redshift. One that's very exciting is the real-time analytics and machine learning piece of this. We talk about that a little further down. You don't have to load your data into the data warehouse. You don't have to load all of your data into the data warehouse. To help reduce costs, you keep your hot data on the cluster, and you move that data off to Spectrum or into managed storage. And so, your scalability becomes, essentially infinite. So you can query gigabytes to exabytes of data in open file formats, Parquet, JSON, ORC, CSV, etc. And with Redshift, with Redshift Spectrum, and federated queries, you can now reach out to your transactional data stores and query them through federated queries. It performs at about 10x performance over its competitors at about 1/10 the cost of an on-prem database. And again, I'm going to go into more about machine learning, but really a great new feature that allows you to run machine learning right out of your cluster. Next slide. And I'm not going to spend a lot of time here. Nasseer is going to go into depth on that, but just a few, highlights to touch on. Like as I mentioned, there's been over 200 new services introduced related to the Redshift family in the past 18 months. Supporting super data types such as JSON, Lambda user-defined functions, which allow you to write your user-defined functions in just about any language, and those functions can speak to other services such as DynamoDB. There's the pause and resume. If you're not using it, cut it off. Materialized views with auto update to those. And so we're gonna, Nasseer is gonna take you for a deep dive into many of those services. Like to always touch on the RA3, very exciting. This is a new generation compute node, which separates compute and storage, thereby allowing you to, scale independently without having to go through, all the here to's and what fors that you have to do when you want to, your clusters scaling massively, ingesting a lot of data. These RA3 instances are, compute and storage separated. And with managed storage, it's automatic. It's built in under the hood. So it's essentially moving that data off to S3 automatically. There are a few different node types in the RA3X, and that range from 4 vCPUs to 49 vCPUs, and from terabytes up to 16 terabytes of memory. So very powerful, very cost effective as well. Next slide. Another new feature is the Aqua, which is a new hardware accelerator, and this goes exactly to my point earlier, where we're bringing the compute closer to the data. It's going to scale automatically, and there's no additional cost for this with the RA3 node types. Next slide. Another great feature, data sharing. This is a great and for the right use case, because it allows you to share data across the organization. So as Ryan was speaking earlier, you have finance, and you have HR, and you have various departments, or however the organization is structured, may have different data marts, different clusters of Redshift. Well, now we're able to, through some fine-grained access control policies, etc., are able to share data between those departments without ever having to move it. So the governance stays in place. There's fine-grained access, and so now finance can, present only the data at the column or row level that maybe HR needs to do some forecasting. And so all the workloads are isolated, so you're not interfering with another cluster's workloads. So really a nice new feature. Next. And here's one of my all-time favorites with Redshift and machine learning. So, you know, traditionally, the real cost in machine learning is not necessarily with the, you know, the creating the models, the training the models, and deploying the models, but it is the inference of those models where the cost is, you know, where the bulk of the cost is, maybe in some cases 80% or better. With Redshift ML, you use simple, you know, your standard ANSI SQL to query that data, and then that data will call SageMaker to train that model, and then present those the results of that model or that inference back to Redshift, which can then be called again through a simple SQL query. And it has the popular, you know, the XGBoost, the deep AR forecasting, etc. Works in a supervised or partially supervised algorithms. And you know, you're paying for the training of the model, but the inference is you're not paying for it because it's part of your cluster. Next slide, please. So just to touch on a few, you know, managed services, and again, Nasseer is definitely going to be taking a deep dive into all of these. But you know, as we stated before, Redshift is a managed service, and a lot of the management is taken care of automatically. You can choose to turn off some of the automatic tuning and features, and you know, roll up your sleeves and manage it yourself. But you know, why not take advantage of, you know, these tools and allow your staff to move from operational task oriented into for development. So you know, there's that. There's automatic sort and distribution keys. You know, workload manager to help you manage your SLAs and you know, your different query groups, and then some advanced monitoring and vacuums and analysis. So next slide. And I want to pause here to see if there's any questions at this point. I know for some of you that attended, this was a recap, and I wanted to try to keep it as short, but felt it only fair that those joining for the first time should get some baseline knowledge before we get into the deeper dive on the optimization. So if there are no questions at this point, I want to take just a few minutes to go over the you know, the architecture, and just try to briefly, you know, pass over that. So, you know, as we stated, it's a managed service. It's a very popular, the most popular cloud data warehouse out there in the marketplace with thousands of users. It's extremely fast. It's highly resilient with a 99.9 SLA. You know, it's secure, encrypted, SOX, HIPAA, FedRAMP, and more compliant. And you can scale from gigabytes to exabytes in several auto scaling methodologies or approaches here. And it integrates with you know, your data lake warehouse. I mean, your data lake, and with the other tool data stores that we talked about earlier through federated queries. Next. It's a columnar data store, you know, and so that's going to provide you with speed and cost. Or we'll get into all the, you know, benefits of why a columnar store is, you know, the correct architecture, data architecture for a data warehouse. At this point, that's a whole other topic for another day. But just to suffice to say that column, the column data resides in 1 megabyte mutable blocks, and these blocks are individually encoded with up to 13 different encodings. We'll get into a little bit more about these immutable blocks and why you really want to look at, being able to split your files to take advantage of the massive parallel processing that's provided through Redshift. Next slide. What's under the hood? Well, when it was announced, it's built on top of the Postgres engine, and that was back in 2013. But it doesn't resemble your father's Postgres. There's been hundreds of improvements and changes to it, but under the hood, it's Postgres. And its seamless integration with the data lake integration is amazing. Next, just to give you an idea of what the different node types look like. You have your RA3s up there, and there's some specifications on it. You've got your dense compute and your dense storage, and that's really workload driven. Most of our customers today that are using Redshift as the single data warehouse and not the data mart approach are going with the RA3s because of the cost savings and the managed storage and some of the other great functionality that's available through that. Super fast and plenty powerful. Next slide. I think we just talked about that. So we can go to the next slide. Oops, that's double. I don't know how that got in there. Keep going, keep going. So best price performance, I'll just finish with that. Scale, concurrency scaling, automatically scaling to virtually unlimited. What's really cool here is, with this concurrency scaling, for every 24 hours your cluster is operational, you receive 1 hour of free concurrency scaling. So, you can get up to 30 hours, 3 hours a month, really, if you're running 24/7 of free concurrency scaling. I believe Nasseer is going to take you through the elastic resize, so I won't steal his thunder there. And
Thanks, Scott. Appreciate all the information. Very informative.
Okay, so I'm going to turn it over to my colleague, Nasseer Slam, and he will take you further.
Thank you. Hi, everyone. My name's Nasseer Slam. Just to start off, I apologize for the worst screen sharing in history. But to get into it, I'm going to be talking about monitoring, optimizing, and managing Amazon Redshift. So to start off, I just want to kind of give an overview of topics. Basically, I'm going to be doing a collection of talking about different features and operations, as well as monitoring, analyze and vacuum different operations, Redshift Advisor recommendations. And just let me know in particular if you have any questions along the way. So to start off with Analyze. Analyze is an operation within Redshift that updates statistical metadata on your table. So this operation is always run when you're changing different keys within your table, adding foreign keys, distribution keys, sort keys, and it's very important. So the query planner is able to choose optimal plans when analyzing your table. A lot of the times you have to remember any operations that you're running on a warehouse is going to be resource intensive. So when you're running it manually, you want to make sure that you're running it in peak hours or not peak hours, and when the workload is very light. And you don't really need to run it on tables that doesn't have any like new data or changes within it. If you run it once and it ends up being just a set table, then you don't need to update it because statistics don't change or expire. So Redshift has started implementing more kind of auto features for a lot of their operations. This one, self-explanatory, it's the analyze operation, but basically automated. So even though it's automated, I still recommend to run some manual analyze throughout the day, on smaller processes and whatnot. But then also utilize the automatic feature that exists where you can just, run it at non-peak hours and late at night. So something to remember is that Amazon Redshift skips analyze for any table that has a low percentage of unchanged rows. So the threshold percent that it has is currently set at 10, but you can update it, as your system grows. And then kind of going into another feature, this is called vacuum. So vacuum essentially resorts rows and reclaims space in your table, and you can specify it for specific tables or all your tables in your database. So basically, you're going to use this similar to any operation, like I said earlier. System performance can be reduced, so you really don't want to run these operations when other, DMLs and whatnot are being or DDLs are being used during the day. And for that, I'm sure you know what's going to be coming next. Yes, there's auto for vacuum as well, and basically, so for auto, same thing. Run it at when the workload's very minimal. There's different features equated to this where vacuum skips the sort phase for any table with more than 95% of the rows that are already sorted. So kind of just take you for an example of when to use auto and manual kind of in tandem with each other. So let's say that you're doing some batch processing within the day and you didn't want to wait for auto, to save the space. You just run the manual vacuum command. And ways to kind of monitor, and I'll talk about specific sys tables later on in the slides. But you want to basically analyze using these various sys tables on whether even using vacuum on your tables is going to enhance your query performance. So we can talk about that a little bit later. And throughout, I forgot to mention, but basically there's this feature within Redshift called Redshift Advisor, and it basically has it's a feature that's powered by machine learning, and it's running these commands in the background that are going to continuously analyze your data and monitor the operations on your cluster and help to predict different issues that could arise. So it's always good, and the issue is going to be high impact issues. So for example, kind of going to the next slide, the types of advisory recommendations, right? So there's going to be data ingestion recommendations, query tuning, table design. Talk about how they could save you cost. A lot of it is definitely saving cost. We talked about the vacuum and analyze tables. There's some features within Redshift that run these automatically. For example, for data ingestion example, if you're running the copy command into Redshift, it runs the analyze command automatically. But maybe use the copy command. One of the recommendations could potentially be you're using the copy command, but maybe you forgot to add compression to your command. So now you have gigabytes of data that is not compressed. So that recommendation will pop up as a high impact, and you update it and save some cost. So continuing with the monitoring, talk about CloudWatch. If you're not familiar with CloudWatch, it's a logging service within AWS, and it's very useful because it can be integrated with other types of notification services. So for example, you can have CloudWatch metrics from your systables to give like an overview of query performance, CPU utilization, disk space, and you can check out the number of queries running at one time. You're basically just monitoring your data warehouse. And you can set up these alarms that will go off, and you can have these different thresholds set where if it's reaching a certain CPU utilization or disk space notification, you can have the alarm trigger a notification to send you an email, text message, or just an alert. So it's very useful, and it's definitely important to monitor your data warehouse continuously. Okay, so I'm gonna talk a little bit about diagnosing query performance. So there's lots of ways to diagnose query performance. My background before BI, I've been BI about 10 years. Before BI, I was doing analyst work and software testing. So those two things were definitely transferable. You always want to do a lot of analysis, and a lot of ways to do that is with query plan, right? So you want to drill down to performance and analyze the execution path of your query. See where you can save in costs, see where you can, change columns around in regards to sort, distribution, and I'll talk a little bit more about that in the next slide. All right, so this actually throughout, I'm going to be talking about a few repositories, GitHubs, that have utilities that are pre-built in queries that can help you with various things, kind of, most common scenarios. So this one that I'm talking about right here is just an extended Redshift monitoring where you can use that utility that is automatically deployed using a serverless application model in CloudFormation. A lot of these metrics kind of go deeper. There are some metrics that come as defaults, but others you'd have to build either on your own or using that utility. And all these metrics are going to be pulling from system tables and whatnot that are continuously run in the background. And I can share the GitHub at the end. All right, so systables, I've been talking about it a couple times throughout my slides. So system tables are basically informative tables about your data warehouse, like metrics and measurements going on about your warehouse. Various things like query usage, distribution of data throughout nodes, SKUs, how your data is being sorted, most high cost queries, things of that sort. So it's always important to have a super user or admin monitoring those systables. I'll talk about different ways of doing that. Kind of just deep dive a little bit about the systables. Like I said, information on queries, information on S3 based data loads, copy commands, things of that sort. Just kind of continue. All right, so again, another GitHub, and this GitHub is basically pre-built queries that are the most common cases that people use. Things like returning the 50 most time-consuming SQL statements in a set number of days. Definitely important if you're seeing that your CPI utilization is running a little high. Got to always analyze and understand. And the automation part that I was talking about earlier with using CloudWatch in tandem with it and getting those notifications when thresholds are being met is very important. Okay, so I'm just talk about a little bit kind of how the query lifecycle works within Redshift. So it starts with a leader node. It receives a query and parses the SQL. Originally, it creates a query tree, and then the Redshift, it inputs that tree into the query optimizer, right? So that's the planning phase. And then the compilation phase, it's gonna compile it, it's gonna generate a query plan, it's going to look at different things like join types, order, aggregation options, and then how the data is being distributed. Different types of distribution, like Scott was referencing earlier, there's single node, there's multi-node, distribution of data I'll go into in a few slides. but yeah, it'll be monitoring everything within the query plan. Then yeah, executing it, it executes and like I've said, accesses different tables to understand like how the segments are running in parallel, taking advantage of saving costs, optimizing network communication, memory and disk management, etc. So, all right. So when you're to look at the query plan, you basically need to run the explain plan. Explain plan, pretty self-explanatory. So you're going to be able to see that query plan that was running. And some of the fields are going to, kind of help you diagnose what to do. It's going to look at different, network expenses and, optimization patterns and whatnot. So here I'll talk a little bit about distribution style. So within the explain plan, you want to be cognizant of how you're distributing your data on a multi-node cluster. So there's different ways to distribute it. You can distribute it all, right? Which basically is distributing the data across all nodes. And you can distribute it evenly, which is basically denormalized queries and tables, whatnot, are not involving joins, or usually when you want to do that. And then, much like other features in Redshift, it allows you to use the auto option. You basically just set it to auto. And from there, as your table is growing, more data is coming in, like maybe it's staying as even right now because it's smaller. And then as it's growing, Redshift will automatically analyze that using machine learning and optimize it to a different distribution style to meet your needs. So it's not a set it or forget it sort of thing. I mean, you should still be cognizant of the different patterns and whatnot. But like I said earlier, understanding query plans and analyzing it is very important. This is just a visual representation of the execution plan for queries. So you can see that it's looking at the aggregates and how much it costs to run that, talking about joins and how long it took to run it, etc. Okay, so just roughly going to touch on the backup and recovery strategy. Having a backup and recovery strategy is definitely important to mitigate risk. The two main things that people are looking at, customers are looking at in regards to the requirements, is how long does it take to recover a cluster, database, or your table, and then when it's done, how recent or up to date is the data, is the restored data going to be? So touching on that more, you're going to be taking snapshots of your data. So a snapshot, for people that don't know, is it's an exact copy of your objects, definitions, tables within your database, essentially your entire database, making a point-in-time backup of your cluster. So you want to, really depending on the use cases that you have, on how often you back it up. But again, with the automated, there is an automated feature that allows you to kind of have the ease of mind. The caveat to this is that automated snapshots are deleted at the end of the retention period. And you can set there's limitations on how long you can set retention periods. But yeah, you can update that as needed. The default is 1 day.
Nasseer, I just wanted to jump in. I didn't mean to interrupt you there. There's also a zero RPO option with automatic failover to another AZ, which is a great way to be able to recover the cluster with zero downtime or minimal downtime and no data loss. So that's another auto feature built into Redshift.
Cool, very cool. Thanks a lot, Scott. Okay, so now that we talked about snapshots, we need to talk about restores. So restoring the entire database using the snapshot. So there's some caveats to this, but you know, basically when you're restoring it, the availability of the cluster, querying and whatnot. So there's going to be limitations in that regard, but essentially you're going to be restoring the snapshot that you took prior. All right, so another GitHub repository. This is a feature that allows you to do restore of a single table from Amazon Redshift Snapshot instead of restoring the entire cluster. So this could be, for example, an employee that accidentally dropped a table, deleted it by accident. Instead of having to restore the entire database, you can just restore a table. So different types of resizing. Scott touched on these. There's elastic resize, there's classic resize, there's also concurrency scaling. So to talk about or start with classic resize. So classic resize, it's pretty similar to elastic resize. The main difference, I mean, you know, pick your node type, number of nodes, etc. But the main difference is the amount of time that it takes to complete. So with classic resize, it's going to take several hours, and the cluster is in read mode during the resizing. And the positives around it is that it has more configuration options than the elastic resize. So elastic resize is limited in the instant types available. So like I was saying earlier, elastic resize is going to be much quicker and 10 to 15 minutes. But you're limited to those instant types or cluster types that you're able to choose.
And that's usually within a family. You can within a family of instances, right? Nasseer,
Yeah,
you're scaling out, but you're not changing from DC compute to RA3s. You're staying within the family.
correct. Yes. Thank you, Scott. Okay. Yeah. So pretty similar with just optimizing cost and performance easily. You can schedule it, and one of the caveats is you can't use elastic resize on single node clusters. And yeah, so you just have to look at the configurations and the use cases of what you're looking for in regards to instant type. So resizing of which to use. Here's some helpful hints of when to scale up and down for workload spikes. Use elastic resize if you wanted higher availability. You can't afford to shut your cluster down to long period of time that classic resize. And then concurrency scaling that Scott touched on. Thinking about scaling vertically or horizontally. When you turn on concurrency scaling, basically the eligible queries that are sent to the cluster are going to be sent to the concurrency scaling cluster instead of waiting in the queue. So as your users grow, it's definitely a good idea to be using concurrency scaling if you have high volume customers throughout the day. There are some limitations that you can't use within concurrency scaling, such as it doesn't support temp tables, doesn't support copy or unload commands, and it doesn't support UDFs. AWS documentation will have a lot of those caveats, and it's usually regularly updated. All right, so for the next, you got to think about the utilization of your cluster and when the right time is to pause it. So, talking about cost, a lot of the time, if and then talking about analyzing different sys tables and running these queries and having these CloudWatch alarms, notifying you of these times. You can start kind of understanding when to pause your Redshift cluster to save on cost. And you can just do it on a schedule and have it resume automatically as your day continues. Okay, next slide. So I'm going to touch a little bit about stored procedures. I'm sure a lot of us with working data warehouses over the years know what stored procedures are. It can be run on schedule. You're using it for various reasons. It could be querying a sys table and outputting it to, having a function pick it up and putting in a CloudWatch alarm that, or notifies has a CloudWatch alarm put into an email that sends it to you. You could do different grants and revokes for access control. And yeah, there's lots of support throughout for using stored procs within Redshift. So in regards to security around stored procs, there's two types of stored procs for security. There's the security invoker. Basically, you have to have explicit permissions to for the underlying objects to be able to run that stored proc, and then the definer essentially need to be a admin. All right, so things that I talked about throughout, analyze vacuum operations, Redshift advisory recommendations, different ways of monitoring and analyzing your queries, looking at the sys tables, understanding different plans, when to take snapshots and use cases of resizing, pausing for saving costs, and stored procs. So let me know if you guys have any questions in the chat, and I'm going to pass it off to Scott now, talking about Redshift Spectrum.
Great, Nasseer. A lot of valuable information there. So I'm going to walk us through one of my favorite features of Redshift, and that is Redshift Spectrum. Redshift Spectrum is a means to offload your data from the cluster. The data resides in S3, and you're able to query that data. So you're gonna, there are a lot of advantages to that, but the number one thing is the cost. You're not as your volume of data increases, you're not continuously expanding or upgrading your cluster. It is a big part of what we do in our practice is to understand those data access patterns, data ingestion patterns, and query patterns to understand that, when Redshift is called for. So leave it on that slide, Nasseer. So yeah, so Spectrum is a built-in feature. You don't have to do anything to turn it on, and it's going to allow you to query data stored in S3. You can query the data from multiple clusters. So this is a key component of the Lakehouse architecture. Also, the capability to potentially query exabytes of data without having to grow your cluster. Excuse me. However, to make this possible, you must have the data catalog enabled, either the glue data catalog or a Hive compatible data catalog. It has to understand where that data is and how that data is structured, and that's all being driven by the data catalog. Redshift nodes expand automatically and intelligently, so you can literally get thousands of nodes of massively parallel processing by utilizing Spectrum. And you pay for it in a manner that is based on how many terabytes of data you scan. And so it's $5 per terabyte scanned. And what is that? My math here, let's say it's 10 gigabytes, that's about 5 cents and I hope my math stays correct there. It's about 5 cents to query 10 gigabytes of data. Very important, and I know Ryan's talked about it. I think we've all talked about it throughout this. The real trick to optimally running from a performance and from a cost perspective is the partitioning of that data and how do you query that data. So compression plays into a big part of that, but you want to make sure that you've given, or working with Mission, we've given considerable thought to how we want to partition that data to improve performance and cost. Next slide. Okay, so this is I think, let's see what the next slide, I think we got out of sync again. The next slide, I want to see what yeah, we can come back to that one. So building a data lake on S3, and this goes back to one of Ryan's original slides. So, we have many and varied data sources throughout the organization that need to get into AWS so that we can then start to bring value to that data and analyze it. So to do so, there are a number of tools and services within AWS native, as well as some third-party tools that will allow us to do so. And so the Kinesis family, whether it's Kinesis Streams or Kinesis Firehose, Kinesis Data Analytics is another part of that family. You can also use Kafka native or managed Kafka. AWS provides a service called Managed Kafka, which takes the headaches of, and for those of you that have worked with Kafka, it's not an easy lift to manage those clusters. And once the data is in S3, that's where the fun begins, right? So we're now in a position to transform it and process it and make it usable and understandable for downstream customers and applications. And it's giving us this opportunity to work with varied formats, data that's arriving in different times of the day. And so there's again, back to the catalog, it's very important that we're cataloging this data through the Glue crawlers or the other meta stores that are available, the Hive meta stores. So crawlers, what they do is they walk through the data in S3 and they identify data types, fields, and all the metadata that's associated with that particular data set, and they store it and make it available to these other services, the EMRs, the Athenas, the Redshift, the Redshift Spectrum. So it's your centralized data catalog. And all the stages are, again, available for downstream consumption. And then finally, there's, going back to the lake formation, which we are a big fan of on our team. We've got a wrapper now, a centralized place to take all of this data in S3 and really put a wrapper around it for governance and security, very fine grained. Within lake formation, you can have database level access and database tables and all that are constructs within this. So now I can provide users in other departments or within my own department or with external customers. I can now begin to share that data with them with confidence and at a very fine grained level of access, from database, table, row, column, and even recently added at an actual cell level. And so, yeah, we're a big fan of that. You know, it takes building the data lake from, you know, months to, you know, weeks, and sometimes even, you know, sooner than that, depending on the sophistication and the level of access control that we need to implement. Next slide.
Did you want to go back to the previous slide?
Yeah, we can do that. So, you know, Redshift Spectrum. It's an ANSI SQL compliant and supports querying data in different formats, you know, and that including JSON. It allows you to, you know, have data compressed and encrypted. Those files. It can integrate with many of your popular BL tools and your SQL tools. We recommend in managing the cost that you keep only the hot data on your cluster and store the warm or even cold data in S3 and take advantage of Spectrum. And so, real key takeaway here, as I mentioned earlier, is compressioning and partitioning to manage the Redshift Spectrum cost. Go ahead. Thanks. Now we go. Okay. So again, we've got you know, different file formats, compressed and encrypted. You know, working with the SQL and BI applications that you currently use. Supports complex joins, nested queries, and window functioning. You know, obviously the partitioning, we go back to that again, by any key. So date, time, or other custom keys. You can create materialized views for external tables. Really nice feature. And then, you know, by keeping the data warehouse lean, saving you costs, and then being able to access your data in S3 without a heavy lift, we see a lot of clients taking advantage of this, and it's really worked out well for them. Okay, so here are a few, you know, just recap real quick. You got the different file formats from Parquet to sequence to, you know, nested JSON, you know, 4 different compression algorithms. Again, I stress that we want to look at the splittable formats, compression formats. It improves load performance and amongst other things. But all of these can be, you know, implemented, and that really depends on, you know, the actual fields within your data set. And so we have encryption, both, you know, server-side managed and then customer managed keys through DAML. A lot of different you know, column types, and then, you know, your tables and table types and the way they can be partitioned, you know, non-partition tables and partition tables. Next slide. Okay. So, you know, fairly straightforward here. How do I define an external schema and table? How do I query this? All this great data that I have in S3. And so the first thing you're going to do is, you know, you're going to define an external schema using the Glue catalog or the Hive meta store. You're going to create an external table, you know, use the external table command, create, and then you're going to reference that table by its schema name and its table name. And then, as you can see, you're off to the races in terms of, you know, querying that data. So not a heavy lift here to access that data, and you're able to, and we'll go into this in a little bit more detail, you know, do complex joins between this data and the data that's resides on the cluster. Next slide. Okay, so how does it work? So, the query is sent through one of your clients to the leader node through either a JDBC or DBC to the leader node. That's where it's compiled and optimized and determined what will run locally and what will go to Spectrum. Then the query is sent to all the nodes in the cluster, and over a 10 gigabit high compute network, and the compute nodes are then going to determine the partition and dynamically prune those partitions. Each compute node uses multiple requests to the Spectrum layer. The Spectrum nodes perform the scan. Spectrum filters, joins, and aggregates the data in S3. And then the aggregation and joins are performed with the data on the cluster. After it's done with Spectrum, it's brought back up to the cluster and the worker nodes, compute nodes, to execute the query, finalize the results, and there you have it. Your results are sent back to you. Interesting feature. We've worked a little bit with this too, with some open source Apache products, Hootie and Delta Lake. Won't go into a lot of detail because it's a little bit more complex because you're doing change data capture, but and some of the SQL statements are a little bit more complex in this regard, but it's very well documented. And if this is something that your organization is already invested in, in its Hadoop Spark environment, this service does exist there. But I will throw in a caveat here that with lake formation, and this is a big reason that we're seeing a real clients get excited about it. Something recently announced, that's in GA now, if I'm 90% sure that's a correct statement, is governed tables. And those governed tables will allow you to do the same thing in terms of change data capture directly in S3 on your data. So very powerful feature. But for those that are more invested in the Hadoop and Spark world, we do have the capability through to support Hootie and Delta Lake. Next slide. So Redshift Spectrum, write directly. This is something that's new. I'm sorry, we missed something. I think I was working on some new slides early this morning and didn't get caught up with everybody. But go back to the Spectrum, write directly. Couple up, yeah, write directly. So this is something that's a new feature. Before you really couldn't write to Spectrum tables and insert into Spectrum tables, these external tables. So you can now write results from your Redshift queries and write them directly to the external tables that exist in S3. Lake formation and a meta store is automatically updated and stored in Glue for all of these, inserts and writes to these external tables. So you can build your materialized views. I think we talked about that a little earlier. You can actually build materialized views on these external tables. So a lot of flexibility there, and some really cool features, I believe, and excited about. So go to the next slide, please. Okay, so runtime bloom filters. what this is, it's a way to improve the query performance. Some benchmarking was done by AWS, and they say they're seeing 2x and up to 10x on some queries, faster performance. And what Bloom is a computer science concept that works on probabilistic formulas. In other words, it uses these probabilistic feature formulas to determine if a data element exists within a given data set. So in some ways that is some sophisticated machine learning, that's going to go out there and be able to tell you, to what degree of probability does the data element we're looking for exist in this particular data set. And what it's doing is pushing that filtering back down to the spectrum layer, before returning any results to the cluster. So it's a query optimization strategy and tooling. Next slide. Nested data. This is a big one. All the different formats that are coming in. Redshift now supports JSON ingestion directly, and so with this nested data using Spectrum, the data is arriving in multiple formats these days. We've discussed that quite extensively, but now with Spectrum, you can query and analyze that data in a nested and semi-structured format. And this is going to eliminate, a lot of expensive and time-consuming ETL to get that data in a flat format, so that can be analyzed, queried and analyzed. So the time to value in implementing this has great payoffs. And it's, it supports other open source formats such as Parquet, ORC, JSON, Avro. And you're simply just writing standard ANSI SQL to analyze this data, to bring back the data and analyze it. Next. So Redshift, Spectrum, and lake formation integration, something that's very dear to my heart. Spectrum, integration with lake formation, and we've touched on lake formation, which is a service that manages security and fine-grained access control government and extends the data lake out to other data stores. So, as we said, we've spoken about lake formation. We work quite extensively on the DAML team here at Mission with this particular integration. Now Spectrum integrates with the data lake. So an administrator is set up, a database, and we go to a database as a construct within the way S3 and is handling the data. But we're setting up administrator role policies and roles that now can go out and build table to column level that can then be applied to the cluster, and then the administrator can then assign those roles and policies to specific users or specific groups. So very flexible in terms of being able to manage your data and do it in a secure fashion. So, for those of us, and that's most everybody, with demanding security requirements, this integration between Spectrum, Redshift, and the data lake and lake formation is it raises the bar. So best practices for Spectrum, we talked on a lot of that. It's columnar. So we want to compress it, we want to partition, we want to compact our data sets. You know, think about the file size, and again, spoke about this earlier, as to how we want our files to be split up. We don't want, you know, large files trying to be ingested into these one megabyte immutable blocks. We want to be able to split this data into smaller files that can fit on the slices. Now, we didn't go in a lot into slices, but suffice to say the slices are within the cluster, is how it logically is separating the data on a compute node. So again, we're Spectrum, we're offloading some of our warm and cold data to Spectrum, and thereby we're not having to resize our cluster constantly, and we're getting a price performance that you know, certainly within our SLAs. And so there's a, you know, as I said, there's a direct correlation between the nodes on the cluster and the number of slices, and the importance of those, of right sizing that based on specific use cases. We want to make sure we get our compute nodes sized properly with the right number of slices, so that we can then, you know, make determinations about how we want to split the data up. Next. So, you know, we hear this a lot. Well, we don't have multiple petabytes or exabytes of data. You know, why should we be looking at this? Well, you know, I think we would all agree that, you know, the data is ever increasing. And, you know, a lot of research has shown that you can see growth in the neighborhood of about 10x, or the volume is about 10x over 5 years, and the data is doubling every year. So, you know, if you're starting out with a small single node cluster, that's great. We can then use, you know, Spectrum and other tools. You know, you don't get to take advantage of the managed storage on the, you know, DC and DS compute nodes. But when you step up into the RA3, you know, you can see a dramatic, you know, improvement. And it's also allowing us to, you know, be able to share this data, as we talked about earlier, you know, around the organization, and feel confident that we've done that securely. Multi-cluster shared data. This was something we talked about earlier, but now we're combining the two. So we have an organization that has multiple data warehouses or data marts in this lakehouse architecture. And we now need to be able to share certain aspects or certain data elements across the organization, and do that securely at a very fine grain level, but not impact the other department or organization within the overall organization, impact on their workloads. So this is where, you know, the multi-cluster shared data concept comes into play. We talked about it, but again, we're isolating these various workloads, but we're sharing the data, and we're not moving the data. So back to the concept of, let's bring compute to the data. Okay, next. So when do I use managed storage, and when do I use Spectrum? Well, with Spectrum, you're going to manage the data in S3, the partition strategies, the file formats, etc. You're going to be able to, that's where you're going to be able to create these external tables. With the RA3 managed storage, all this is managed under the hood by Redshift. and the compute nodes. And so automatically it's swapping the data between S3 and then back to the cluster as Nasseer mentioned, some of the auto ML features that are running in Redshift are managing that for you. So it's transparent to you. It's no different in how you ingest, access, or load the data when using the RA3s and managed storage. Excuse me a second. Go to last slide. How to choose. So we look at the bottom, we have Redshift, we have Athena, and we have EMR. And the data warehouse is going to be highly relational with complex joins. We're going to need sub-second latency. We've got a join between data in our warehouse and in S3 and potentially other data stores through federated queries, as we spoke of. Then we have, Athena, which is a great tool, and we use it quite a bit. But this is more for like interactive queries. It's serverless. We don't have to have a data warehouse. We can query this data directly out of S3. And it really is used for more, ad hoc queries. We use it quite a bit to build views, depending on the use case, for our downstream BI tools, such as QuickSight. And we find it to be a very helpful tool. It's not an end-all, be-all for everybody, but it's serverless. You've got no servers to manage, and you can query your data directly in S3. And then with EMR, we're processing just large volumes of data, and you as an organization have made an investment in Hadoop, Spark, and want to use some of those, those Apache tools like Presto and Hive, and then you want to be able to run, your Jupyter notebooks on that cluster in real time, near real time. So, okay, any questions? That ends the session on Spectrum, and be happy to take anyone's questions. I know we've got some time on our hands, so feel free. Oh, great, another poll. Great. So, which one of the following database technologies do you currently use? Oracle, SQL Server, Teradata, Ateza, or another? We're in a few minutes. And the results are in. Wow. SQL Server, 100%. That's interesting. I don't think I've ever seen one of our polls come back 100%, but thank you for sharing. Okay, let's move on. So how can Mission help? As Ryan, spoke about very early on, Mission is a premier AWS partner, gives us access to, some of the latest and greatest features that are being offered, various funding opportunities that help our clients get off the ground. We have hundreds of certified AWS professionals, and along with a number of competencies as well. But we engage with clients in several different approaches, and that is one, we have the standard professional services where we come in and scope a project, put together an SOF, and deliver on that project. And then we also have a more sprint-based model where the customer says, we work together and determine, well, we really don't know exactly what we're looking to do here, but we know you guys have have the experience and the roadmap. So let's just go at this at a sprint base, a weekly sprint base, build the backlog, knock it out, move on to the next backlog. But then we go a little bit beyond that and offer. A lot of our clients came to us and said, it's great that you guys come in and help us architect and implement and build these systems, move them to production. But we don't have the internal resources to continuously upgrade the systems and continuously, take us to the next level in our, analytics and machine learning practice. And we would like to engage mission in an ongoing basis. So next slide. So we have something called managed data ops, and we have several different flavors of that, which we will go into at the next slide. So there's the calibrate and tune. So you already have some infrastructure in place, and it's operational, but it needs fine tuning. It needs probably maybe some retooling, and we can adjust the performance and efficiencies of that, potentially saving you costs and increasing your, not increasing, but decreasing your SLAs. So we have the technical expertise to work with that. And what this is it's a pod-based system. So someone, let's say like Nasseer and I were assigned to your organization. We would have, you would buy so many hours of the data consultant and the data engineer and a project manager on an ongoing monthly basis. And, again, we would do sprint models and continuously build out and improve your architecture and your systems. Go to the next one. And then there's the design and build piece of that. And what that is, hey, we're just getting started. We need, our old legacy analytics system, we know we've outgrown it. We've got some technical debt. And we want you guys to come in and design this thing and build it for us, and then continuously help us improve it, and maybe introduce new concepts. What we see a lot is customers will say, we want to move to a data lake and this modern data architecture. Help us get there. And once we get them there, they're immediately saying, well, now we see how we can really take advantage of, some machine learning or AI capabilities within the organization. So again, it's a pod, and it varies in the number of resources and the number of hours that you would sign up for. So go to the next one, please. No, there's not much there. Move. It's just a continuous model. Go to the next. Again, so we have a diverse set of skills and expertise across these cross-functional pods. We have also not only data engineers and data consultants, but we have cloud engineers that can help with deploying infrastructure as code, although we do a good bit of that ourselves, but we have a whole team that is devoted to building infrastructure as code, helping refine and and harden the architecture with, IAM policies and roles and, cross count access, etc. So we can, we have the ability to scale up to meet your, additional capacity, and we're going to reduce your management overhead. So I guess we go to the next one. And so a little small here, but you can see under the calibrate and tune, what you're going to get there. The data consultant up to 8 hours a month, the design and build up to 20 hours a month for a data consultant, that's going to help you architect, develop a strategy, align with business goals, and review code. And then the data engineer, calibrate and tune is 40, and design and build is up to 80. And then what they're doing there is, helping you build out visualizations and can do some basic ETL work there. Not that they're not capable of it, but that's what the service aligns with. And in the design and build, you're going to get more advanced ETL and design of the data lake and data ingestion jobs, etc. And then with the there's the project management, and then we also have the ML ops is another area that we're highly focused on. And with that, we can open it up to questions again. If you don't have questions, are shy today and don't want to ask questions, we'd be happy to have you email us. I believe we have, as Ryan mentioned earlier, where we have a free consultation for those of you who stuck around this afternoon, that reach out to us. Melissa has all the requisite information to get in touch with us, and either myself or Nasseer or one of our colleagues will be happy to address those questions. With that, we'll stick around for a few minutes, but if nobody has any questions, it's certainly a pleasure to have you here today, and we enjoyed presenting to you, and really would hope to have further discussions with you and your organization about how Mission can help your organization build a modern data analytics and machine learning solution. I'm going to take silence as a...
Thanks, Scott. It was a great presentation.
Well, likewise this year. But again, I hope everyone enjoyed it. I hope you found it informative. And we will continue to be doing these webinars. So, excuse me, I've been talking too much. But yeah, we're here to answer any questions that you may have, and would look forward to working with you. Melissa, do you have anything in closing in terms of a poll, or if not, we will give everyone back 15 minutes of their day.
Sounds good. Thank you, guys.
Okay, great. Thanks, everyone.
Okay. Wonderful. Thank you, everyone. Have a great afternoon. Bye-bye.